All right, we're going to go ahead and find well, let me go back and say to solve a triangle is to find all the missing side lengths like this one, DE is missing, and find the missing angles, angle E and angle D. So as Grant suggested, let's go ahead and find angle, let's say E. We could find either one, but let's just zoom in on angle E. And you said it right, that the tan of angle E is going to be equal to, let me write that down, tan of angle E would be equal to something over something. Luke, can you say that?
Yes, tan over E equals something.
Yeah, it's going to be something over something.
Over adjacent and something.
All right, give me some numbers. Give me numbers.
Jesus.
It would be opposite would be 12 over 5.
Exactly, 12 over 5. That's exactly what we're looking for. All right, now listen carefully. Once we know 2 of the 3 green lights, we can go ahead. Again, we know the 12, we know the 5, we can find the angle E. So we can do it a couple ways. Let me just go ahead and get the decimal for this. 12 divided by 5, I think I know what that will be. What is it?
2.4.
It's going to be 2.4. And let me stop right here and see if someone can remember how can we find a measure of an angle given the tan of the angle. Victoria?
We find tan to the negative 1.
Excellent. We go tan to the negative 1. Tan to the negative 1 of that decimal which we just got. So go ahead and write that down. Even if you didn't get it, just go ahead and write it down. And we'll go ahead and find it. I'm going to round this to the 10th place as they ask us to do. So, tan to the negative 1 of 2.4. I'd like someone to do that in the calculator and I'll have a confirmation on it. Priscilla, go ahead and do that. Tan to the negative 1 of 2.4.
I got 67.3.
Confirmation, anyone? Confirmed, Grant? Maddie? All right, let me write that down. 67.3 degrees. All right, so that's one missing angle. Remember, we're solving a triangle, so we want to find everything that's missing. Got that one. So now this one, I'm going to look at angle D. Is going to be fairly easy for us. Grant mentioned up front how we could find angle D. Do you remember what he said, Penelope? How could we find angle D? Knowing angle E, this is already 90. Knowing angle E now, we should be able to find angle D very simply. Ariella, how can we find angle D? You could do that. There's an easier way though. Who can give me the easier way? Go ahead, Grant.
You can subtract 67.3 from 90 because you already have those two angles. So you can just find D by that.
Exactly. These two angles, E and D, must add up to what? 90 degrees, yes?
Yes.
No, you agree with that? So we're going to take 90 and subtract the 67.3 from it, and that should give us angle D. Let's go ahead and do the borrowing here from here. 10 would be here, but then we have to borrow 1 from the 10, leaving 9. So now 10 take away 3 would be 7. 9 take away 7 is what? 2. And 8 take away 6 is 2. I got 22.7. Some of you got 22.6? All right. Yeah, maybe it's a rounding situation here, but that's close enough. I'll take that. All right, so 22.7 for angle E. We're almost done. We got this angle and that angle. We're only missing this side here. We're going to go ahead and find that side length. Yes? Is that what you got? Oh, so we might have made a mistake on it. Or maybe that's why I'm coming up different here. All right. Yeah, I'm going to have to check that. But the method here is good. You just have to look at the calculator maybe a little bit more accurately next time. One more missing element here is this side length. I'm going to call it X, the hypotenuse. I want to go ahead and set up a relationship between X and 2 other known features so we can find X. wonder if someone could suggest whether we can do cock, toe, or soap for that. Tiffany, I see your hand.
You could do sine.
Sine of which angle?
You could do, D, no, E.
Yeah, you're right.
And
Sine.
it'd be 12 over X.
All right, let me write it this way. Sine of angle E. Well, we already know that angle E
Is,
is 67, right?
Yeah.
67.3. Let me write it. 67.3
and it'd be 12 over X.
is going to be equal to the opposite, which is 12 over the hypotenuse, which is x. Let me write that down. 12 over x. I wish I could write better on this thing. But anyway, maybe some of you might be able to do it. Sine 67.3, I'd like somebody to go there right now with your calculator, Bridget. Sine 67.3 and get a confirmation on that.
0.9225.
Okay, give me 4 places. Confirmation on that 9. Confirm. 9. Say it again, Bridget.
0.225.
Oh, it's 6 too? I thought you said 9.
It's 0.9225.
Oh, sorry.
I got
9.
0.9230.
Oops. We'll have a confirmation on either of those. Josh, what do you have?
0.9225.
225. See if we're confirming that. All right, let's just use that. It's going to be equal to 12 over x, and we've done a number of these before. We should have, even on your homework. So let me stop right there now. Jessica, how can I solve this to find x? We're going to cross multiply, yes. This it should be just, should be able to do it even almost in your sleep. 0.9225 x is equal to 1 times 12, which is 12. I'm going to go ahead and divide both sides by what, Alex? No, not by 12, by, look again.
Oh, by 0.925.
Yeah, 0.9225, that will be gone. This side by 0.9225, and the x now, even if you didn't do it, I'd like you to go with your calculator, 12 divided by that to get an answer, and want Daniela to give me an answer, and let me get a confirmation from someone.
13.0.
Yeah, that's exactly right. 13 confirmation, yes, 13.0. So that's a third feature which was missing, which we found. Any of you got that before me? Because I know some of you, Austin, you got it. Priscilla got it. All right. Let me check one thing with you right now. Can any of you see that there's another simpler way of finding x, even without using the trigonometry here? I see 2 hands. Abby?
Yeah.
C squared equals A squared plus B squared.
Excellent. You heard what she said? Yeah, she said c squared, which is the hypotenuse squared, equals a squared plus b squared. I'll accept that. In fact, let's go ahead and do that for a confirmation. C squared, in this case, would be x squared, is equal to a squared plus b squared. That would be 5 squared plus 12 squared. All right, I'd like you to write it down because this is maybe a little bit more familiar way of doing it. Bridget, not Bridget, Blacy, what's 5 squared?
25.
All right, we got 25 plus 12 squared. 12 squared, David?
144.
144. All right. Hope I have enough room here to finish it. This is 169. That's what x squared would be. And from there, Jessica B, how do we get x from x squared? No? Roger, do you remember if once we have x squared is 169, how do we get x? Factor 3? You're close. You're close. Amber?
Root it.
Take the square root of it, yes. Square root, root it. Yeah, I know what you mean. Square root of 169, any of you remember that without a calculator?
Yeah, man.
What is it?
13.
It's 13, and that's what we got somewhere before. The same as this right here.
I got 13.1.
All right. Yeah, think just the rounding, I'm gonna have to maybe show you a little bit better how to round. Alright? So, that's pretty much how that works. I'd like to give you another one from a worksheet so we can work on that. Let me see. How
Pull up
much?
a worksheet on there?
I do. Let me finish this diagram here. Here's another one. On this diagram, this is 70 degrees here. And what else we have? We have 15 for the hypotenuse. And that's pretty much what we have. All right, I'm gonna ask Grant to help me to give this worksheet out so we can start working on this. When you get the worksheet, look at number 15. We're gonna work on 15 to get some more practice on solving triangles. Again, worksheet is coming. Number 15. You'll take a little bit more practice here. As you look up there, what is missing? Look at what's missing because we're going to solve that triangle as well. We're missing which angle?
You.
Angle U or
Missing you.
you or me?
Jessica. Huh?
You or me?
Missing
Are
you.
you still recording?
Missing you.
Yeah.
All right, angle U, but that's easy to find. Can we find it real quick? Who knows what angle U would be?
Me.
Miami.
20 degrees. How many can see that? It's kind of a giveaway, that one. Thank you. All right. Yeah, look at this. Angle U is missing. Right here. I have my pen. Yeah, U is missing, but we can find that easy because since it says 70, somebody suggested that angle U would be 20. How many can see that right off the bat? Roger, can you see that? Angle U would be 20 degrees because angle S plus angle U add up to 90. So right real quick we could say measure of angle U is equal to 20 degrees. So we're done with that. Alright, but what else is missing?
Other side legs.
Yeah, we've got the hypotenuse is 15, but we're missing the legs, yes?
Yeah.
Alright, so we want to set up a relationship either by ka, toa, or so in order to find these side lengths. Let's maybe give it, let's give this x, make it short, and this length y. Alright. Let me ask someone to suggest, Noah, how could we set it up in terms of cosine, sine, or tan to find, let's say, x. We know this is 20 degrees right here. We know this. Let me just put that in there. That's 20 degrees. We want a relationship involving x where we know 2 out of the 3, and x is the only thing that we don't know. How could we do it?
Sine of x.
Sine what?
Sine x.
It's always going to be sine of an angle. So it's going to be either sine of 20 or sine of 70 or tan of 20 or tan of 70.
So sine of 70.
Okay, cosine of 70, let me write that down. Cosine 70 would be equal to what? Give me the numbers.
Point. 15 over x.
15 over x. Let me write that down. Cosine ka is equal to what? Adjacent over hypotenuse. So think again. No. Cosine of 70, here's the focus right here. Cosine of 70 should be what over what? What's adjacent to angle 70? 15 is the hypotenuse. What's adjacent to the 70-degree angle? You know why?
Why? You're so funny, Mr. Henry.
It's the neighbor, but it's not the hypotenuse. It's the neighbor. Okay. The hypotenuse is in a class by itself. The hypotenuse is, okay. No, the hypotenuse is the hypotenuse. It's never the adjacent. So it's going to be y. You got the adjacent now. Over hypotenuse would be, come on. Finish it.
15.
15. Now take a look. We know 2 out of the 3 we can finish it.
Yes.
0.3420.
All right, yeah, let's go ahead and do that. Luke, what's cosine of 70?
0.3420.
Oh,
Confirmation someone.
me,
Amber,
he's
point
correct.
3420 is equal to
That's an 8.
y over 15. We're going to go ahead and do the cross multiplication, as you know. It's like a 9, but it shouldn't. It's going to be y times 1 is y. And the answer is going to be 15 times 0.3420. Maddie, I'd like you to work that out for us. And we're rounding to the 10th place.
I know what you did.
Maddie,
Yes.
work that out. 15 times 0.3420.
You did.
Should I call your name?
Yes.
Okay, no. What is it?
5.17.
All right, 10th place, 5 point. No, it's just one number after the decimal for the 10th place. 5.1. Okay, any confirmation on that one?
Yes.
Amber, Victoria. Okay, so I got y. I'm only missing one side length, and I want to find a relationship involving x, such that x is the only thing I'm missing. Victoria, take a look and give me a relationship either by ka, toa, or so, that I can find x. Cosine of which angle? Angle U, I think so. Cosine of 20, let me write that. That's exactly what I'm looking for. Cosine of 20 would be equal to, give me the ratio. Victoria? Now look up here. Cosine is adjacent over hypotenuse. So what's adjacent to 20? Huh? X over 15, yes. X over 15. All right. Cosine of, I don't know what I wrote there. What's that, 20? Cosine of 20. Blaise, you have a calculator? Amber?
You get 0.9397.
All right. I'm looking for a confirmation from someone. Joey? All right, 9397, okay, equals x over 15. We're almost done with this one. Let me stop right here. Cross multiplication coming up. X times 1 is x. Answer is going to be 15 times 0.9397. Penelope, work that out for us.
Here you go.
Make it quick. Confirmation on that as well. Roger, you have a calculator? Okay. 14.0. All right. 0.1. Confirmation for anyone? Okay, got a couple of 14.1. All right, so we've solved the triangle. We found all the missing angles. There was only one. And all the missing sides, there were 2. This one now becomes 14.1. And that's pretty much all that we need to do, Austin, in solving a triangle. And that's similar to what God does for us. Whatever is deficient, whatever is missing in our lives, Jesus is a solution for it. He always is. Right? So let's